All right, my friends. Good morning. Today is Thursday, March the 26th. And today we're going to talk about section 10.5, thermal energy. Okay. Obviously, thermal energy is the energy of heat. And so what we're going to talk about is first, what is heat really? How does it affect an object? And secondly, how is heat actually generated? So, thermal energy, of course, is simply the sum of all of the kinetic and potential energies that are found inside the molecules in atoms. All right, the photographs on the right hand side show a hot metal and, of course, an ice cube. And in the hot metal, you can see that even though the atoms are all bonded to each other, they are wiggling around. That's what this is. So they're moving very, very quickly. So even though it's a solid and the molecules are not able to move freely, they are still rapidly vibrating. On the other hand, in the cold object, the ice cube here, you can see that again, the molecules are all bonded to one another, or at least attracted to one another, but they're only moving slowly. Okay, and that really is what temperature is a measure of. How fast are the molecules of a substance moving, even if the substance is still in the solid phase? So here, this is kind of a neat little diagram. It shows a box being dragged along a floor, and this is done with a thermal imaging camera, and you can see that heat was generated along the path that the box was pushed or pulled or whatever it was, and that's because of the friction that exists between the floor and the box. Okay, so friction on a moving object does work. All right, and this work creates heat. So how do we actually look at this? Well, remember that the change in any kind of energy is equal to the work that's done on it. So if we're going to talk about thermal energy, and we know that thermal energy is generated by friction, then we use the formula for work, right? Force times displacement. But the specific force that we're going to talk about here or use here is the force of friction. Okay, so the thermal energy equals the force of friction times the displacement of the object. So let's look at this example here. A 0.30 kilogram block of wood is rubbed back and forth against a wooden table 30 times in each direction. All right, so back and forth, back and forth. All right, 1, 2. The block is moved 8.0 centimeters during each stroke and pressed against the table with a force of 22 newtons. So you're pushing down on that block with a force of 22 newtons. How much thermal energy is created in this process? Okay, so how do we look at this? The hand holding the block does work to push the block back and forth. All right, so you're moving it back and forth here, doing work on it. That work transfers energy into the block and the table system, where it appears as thermal energy according to the equation that we just talked about in the previous slide. The force of friction can be found from the friction formula. F sub k equals mu sub k times n, where mu sub k is the coefficient of kinetic friction and the n is the normal force. And if we look up the coefficient of kinetic friction for wood on wood, we end up with 0.20 as our mu k value. Now, the next thing that we need, of course, is the normal force. All right, we know that the normal force is the opposite of it's the upward force in this case, assuming that we've got a horizontal surface, and it's got to be equal and opposite to the sum of the weight of the block and the force that you're pushing down on the table with. So we need to figure out weight, and we need to figure out this force. Now the force F is 22 newtons. So remember that from the previous slide. But if we look at these, we look at the sum of all of the forces in the y direction, we know that it's going to be the normal force minus the weight minus the force of friction. And that, of course, according to Newton's second law, is equal to m times a. But because we know that the block is not sinking into the table or bouncing up off of the table, that total force has to be 0. Therefore, we can say that the normal force is equal to the sum of the weight plus the normal force, right? Just add W and F to both sides. All right. And so 0 plus W plus F is W plus F. The weight, of course, is equal to mass times the acceleration of gravity. I know that the wooden block has a mass of 0.30 kilograms, and the acceleration of gravity, we're assuming we're on Earth, is 9.81 meters per second squared. We multiply those together, add to that the 22 Newton force that I'm pushing down with this block or on this block with, and I get a force, a normal force of 24.9 newtons. So then I can go to my Fk equals mu k times n. I know that the coefficient of kinetic friction for wood on wood is 0.20. I just calculated the normal force is 24.9 newtons, and that gives me a frictional force of 4.98 newtons. Now, we're not done yet. That's only calculating the force. Remember that in order to figure out the thermal energy, I have to figure out the amount of work that's done. And work, of course, is the force of friction times the displacement. Now, if I go back and forth 8 centimeters 30 times, that's actually 8 centimeters times 60, because there is 8 centimeters and back is 8 centimeters. So it's actually 16 times 16 centimeters times 30, which gives me a 4.8 meter displacement. Finally, I go down to my thermal energy formula, force of kinetic friction times displacement. So 4.98 newtons times 4.8 meters, and that gives me a thermal energy, an amount of heat of 24.0 joules. Well, 24 joules, close enough. All right. And this seems like a reasonable amount of heat created by rubbing one surface on the other. Okay, you can do the same thing in your own living room here. Vigorously rub a somewhat soft object, such as a blackboard eraser, on your desktop for about 10 seconds. If you then pass your fingers over the spot where you rubbed, you'll feel a distinct warm area. All right, congratulations, you've just set some gazillion atoms into motion. Now, we did this, if you recall, one of the last days that we were in class, I gave you each a tennis ball and asked you to rub it on your desk and to see how warm you could make the desk. All right, you generated heat by using friction. Okay. Your homework for this evening, gentlemen, is numbers 24 through 27, odd numbers only, in section 10.5 at the end of chapter 10. All right. Happy Thursday. And tomorrow, I will expect you to be working on the third review chapter in your AP review books.